Good morning or good afternoon, everyone. Thank you for joining us, and welcome to our webinar today titled Evaluating and Quantifying the Non-Energy Impacts of Energy Efficiency. This webinar will run for about 75 minutes, during which time we have 4 presentations after my introductory comments. Just to let you know, all the phone lines for the audience are muted. If you do have questions, please type them into the text box, and we will do our best to get them all answered today. The webinar is being recorded. The recording and slides will be available at the LBL webinar website, which is listed on this slide of the presentation and some other ones. And we'll hopefully get that up as early as later today or tomorrow. I also want to mention that the funding for this webinar is from the U.S. Department of Energy's Office of Electricity Delivery and Energy Reliability. And LBL is coordinating the series with input from and collaboration with DOE, of course, as well as the U.S. EPA, the National Association of Regulatory Utility Commissioners, and the National Association of State Energy Officials, who I want to thank for their support. So please let me start off with introducing myself. My name is Steve Schiller, and I'm an affiliate and senior advisor in the Electricity Markets and Policy Group at Lawrence Berkeley National Lab. I've worked in the energy industry for many years with a great deal of that time focused on efficiency and demand response. And one of my areas of expertise is evaluating measurement and verification. And I'm very fortunate to be the facilitator of this webinar series. LBL, which is hosting these webinars, is supported by the Department of Energy to conduct non-classified research, and it's operated by the University of California. LBL, also with funding of the Department of Energy, provides technical assistance to states, primarily state energy offices and utility regulatory commissions, as well as other entities, public entities in our country. Before I say a few words about the technical assistance, though, let me just mention our disclaimer here, which essentially says that DOE, LBL, University of California, and pretty much anyone else doesn't take responsibility for these other than the speakers and myself for what we're about to say. On that technical assistance, LBL provides independent and unbiased assistance for state utility regulatory commissions and state energy offices, as well as tribes and regional entities in a wide range of energy areas such as efficiency and demand response, renewables, and grid topics. Contact information for the technical assistance is available via the websites listed here. And for those of you who don't write too fast, again, these slides will be available on the LBL EM&V webinar website probably by tomorrow. And if you don't have that site handy, you can just Google LBL EM&V webinars, and I believe it's the first one that shows up that's not an advertisement. So this webinar series are designed to support activities for documenting energy savings and other impacts, such as we'll be talking about today, of energy efficiency programs. And as mentioned before, it's funded by DOE, and again, I want to thank EPA and NARUC and NASIO, and organizations such as several of the regional energy organizations, the Consortium for Energy Efficiency, and the International Energy Program Evaluation Conference, which help us with our outreach, which is perhaps how many of you found us here today. Our target audience for these is utility commissions and state energy offices, environmental departments, and nonprofits involved in operating efficiency portfolios. But we also see it as value to many others, and you're all certainly welcome. We expect more webinars on these topics, and they'll be noticed on the webinar site. Again, contact information indicated here, and will be in the posted sites. For our next webinar, we're currently scheduling something for the end of January, maybe the first week of February, and that's planned to be on opportunities and approaches for reporting consistency and coordination around energy efficiency EM&V. And we plan on doing some additional webinars through 2017. So for today's webinar, we're going to talk about non-energy impacts of energy efficiency. It's an interesting term since energy efficiency by definition is about energy, but there are impacts from efficiency other than the direct energy and demand savings. Some examples are listed here on the slide, such as reduced pollution and economic development opportunities, and more will be listed and described during the later presentations. While these impacts can be positive or negative, in most cases the non-energy impacts have been shown to be positive, and that there's an overall benefit outside of any direct energy savings. And thus, they're often called NEBs or non-energy benefits. You'll see the term often in the literature and in our presentations today. We'll talk about a number of aspects of these NEBs, including their evaluation, which will be particularly covered in the next presentation. As I mentioned before, we should have some time for clarifying questions after each of the 4 presentations, and we've scheduled some time at the end to answer your general questions as well, perhaps in the last 10 minutes or so of the webinar. And again, for those of you maybe joining a little later, the audience, you're very welcome to be here, but your phone lines are muted. If you have questions, please type them into the text box, and we'll do our best to get them answered. And again, it's being recorded with the recording and the slides available soon on the LBL EM&V webinar. I've listed our speakers here today. I'll be doing introductions as we start them off. As I mentioned, we've got 4 excellent, experienced folks in this field who can talk about non-energy benefits and impacts from a variety of perspectives. And let me just say before we get started with our speakers that, why are we looking at non-energy impacts? We often focus on the cost savings or energy savings in our assessments. However, for the policymakers and the utilities and consumers who are considering these non-energy impacts, they really find them quite important in their decision making. For the policymakers, for the economic development, the pollution avoidance, providing a reliable resource, utilities, for providing price stability, distribution system upgrades, avoidance or delays, and then participants often see these non-energy benefits as the real drivers for their decision to move forward. Thus, as I think Lisa, our next speaker, is going to be talking about, as well as our other speakers, we'll be talking about the importance of why we understand and quantify these non-energy impacts. So it affects, the cost-effectiveness analysis to get the full range of values and costs, but also for program design and marketing. So with that, let's get on to our speakers today. We'll have Lisa Skumatz will be our next presenter, followed by JP at Berkeley Lab talking specifically around energy performance contracts. And then Jessica and Matt are going to be talking about their experiences in their states in looking at and using these non-energy impacts. So with that, I'm going to pull up Lisa Skumatz's first slide. Lisa is a PhD economist. She has over 30 years experience in efficiency evaluation, and she's the head of research in her consulting firm's SERA, as well as a nonprofit E-Conservation Institute. She's formerly worked at national labs and utilities, and she has really pioneered the non-energy benefits work in our industry, particularly the quantitative and applications work in NEBs. And she has over 50 papers and conference proceedings in referee journals. So I'm really fortunate to have Lisa here today. And with that, Lisa, I'll let you take it away. Thank you.
Thanks very much, Steve. And hello, everyone. I'm Lisa Skumatz, and I'm going to talk about non-energy benefits or non-energy impacts, what we've learned in 20 years, the status, and what's next. For non-energy impacts or non-energy benefits, they really represent the value from the programs and measures beyond the savings that we were initially after. There's been 20 plus years of research and study and progress on these metrics, and you might ask, why did I and other people get involved in non-energy benefits? And it's really because we know that when we're looking at benefit cost analysis, when we're looking at that kind of stuff, we know that 0 is the wrong number when we're looking at what additional benefits beyond energy savings are in a benefit cost analysis. Benefit cost by definition in economics says the benefits over the costs, and you're looking for a certain ratio. If you're missing a number of the benefits, anything beyond energy savings basically, then by ignoring them, you're assuming there's 0. We know we can do better than that, even if it's ranges, and maybe we can even do better, and that's kind of how I got involved. Can we bracket these? Are these important? Are these big? The other reason that we get involved, I think, is that people realize that customers, consumers, businesses, etc., look at these measures, and they don't only look at energy savings. They look at measures and programs providing them a bundle of features, and our tunnel vision doesn't affect the fact that they're making rational decisions based on things well beyond our just energy savings. Furthermore, some of the initial research that we did showed that they were very high value, so that when we're looking at benefit cost applications among the wide variety of other applications, we're really not including all benefits, and they are significant numbers, and so we really are biasing some of the benefit costs and the decision making that we're doing. There's been 20 years of progress in NEBs, and starting from the lower left, it started early on with lists of NEBs. What could NEBs be? Then we did research saying, well, who are the perspectives? Who benefits from NEBs? And came up with the utility, society, and participants, all as beneficiaries of things beyond energy savings associated with programs. We came up with the initial measurement approaches and estimated some of the first NEBs, particularly in the low-income field. The next box talks about sort of exploring the benefit cost approach. So early on, we looked at whether or not benefit cost programs metrics should change. But there was a little bit of pushback because people were concerned that wasn't, in fact, the literature wasn't robust enough to go there yet. The next period, we looked at more and more measures and measurement of NEBs in programs across the U.S. and internationally. And finally, more recently, we've come back to looking at benefit cost as an area where NEBs is important and looking at exploring those measures. One of the things that we look at is, we see 5 major applications of NEBs. That includes marketing, trying to figure out what it is that will appeal to the customers we're trying to sell programs and measures to. Program refinement, what are the positive and negative NEBs being barriers that we need to consider as we're designing our programs and figuring out how to make them most impactful and most attractive and how to provide incentives to really bring people in. Training the chain says that all the actors that are delivering our program need to understand the NEBs that customers realize and make sure that they're aligned in the NEB priorities and make that message clear. Policy and goals was one of the first things that NEBs came up because of. So we were looking at low-income programs initially. Low-income programs are not about energy savings. They're really about other policy goals. These NEBs measure that. Finally, benefit cost tests, trying to refine and better address where our investments ought to be without bias. The main NEBs perspectives, utility, society, and participant, include a variety of NEB categories, including on the utility side, financial things like arrearages, bad debt, insurance, and reliability issues. In societal perspective, we're talking mostly economics and emissions, health as well, and some other infrastructure. And on the participant side, for the residential sector, we're talking things like comfort, control over their bills, shutoffs, noise, and savings on other bills. On the commercial side, we're talking productivity, indoor air quality, lifetimes, maintenance, and other kinds of things. Lots of work has been done in how to measure NEBs, and there are 4 main measurement approaches for NEBs. That includes direct measurement, secondary measurement, models, and surveys. In all of them, we're trying to get to monetize NEBs. For direct measurements, we're talking corporate records and utility data, like arrearage studies and so on, that tell us what dollars are not being left in arrears. Secondary measures are saying, let's do a study, figure out what the change in a particular thing is, like, let's say, the number of calls to a utility or the length of calls to a utility about bill problems. Multiply that times the marginal per hour rate for a staff, and you can about the financial calculations that get to secondary data. Might be insurance claims as well. That's another example where we use secondary data. A third approach is models. In that case, we're talking usually about third-party models that model the economic impacts or job impacts of these programs and measures. And the other approach that we often use models for is emissions, looking at what kind of emissions we're getting. The last part, and the one that really was the longest to sort of mature, was the work in surveys, figuring out how do you measure things like comfort. You could think about it as bulb temperatures and all the rest of that stuff, but really comfort is something well beyond just the temperature in the room, but it's a perception as well. And surveys really are the best ways to measure some impacts. But how do you get about that? Traditional literature says do willingness to pay. But when, it didn't take very long to ask a few willingness to pay questions for people to say, I can't answer that, that's a dollar thing. So one day as I was driving to the ferry, I realized that while people may not be able to answer how much would they be willing to pay for a less drafty window, they might be able to tell me, is it more or less valuable than something else that I do have a dollar amount associated with? And that turned out to be a way that we could find approaches in the literature and really take off and do very academic and very defensible approaches for figuring out what are the NEBs and how do we value those. We often use multiple methods and triangulate to numbers, and as I mentioned, surveys are appropriate for most. What I'm really looking for is, how can we have good, reliable, large sample size, not unbiased numbers, and that's what we're really after. And that's what we're trying to do here. The way that we, when we're talking about participant NEBs, not only have we said willing to pay isn't fruitful, but we've explored 7 other better options for figuring out how to figure out the savings, and there are pluses and minuses associated with each one of those. One that we kind of landed on is labeled magnitude scaling, which says, is it much more valuable, somewhat more valuable, and all that sort of stuff than the energy savings as in many cases. It's something people can answer quickly, and we can get large samples of data from it, and it has statistical and academic information behind it that really it makes it a powerful approach. But there are many other approaches we've tried and used and have had good success. Best measurement approaches says that we need to have sort of net 3, as I like to put it, net positive and negative NEBs, net beyond standard efficiency equipment that would have been installed otherwise, and net considering net to gross. We also want to make sure in our surveys the things we're talking about are non-overlapping, and we want to ultimately come out with consistent units per household or per customer per year or something like that so we can add them up in a sensible way. This measurement of participant NEBs has been robust enough that we actually have been recommending that they be included in all process and in whatever impact evaluation surveys are done, partly because they really strongly represent the benefits of the program. They also represent negative impacts of the program. That's why we sometimes call them non-energy impacts rather than just non-energy benefits. But those negatives represent barriers to the program, things that you can address through your program design. Moreover, it gives you dollar value for the negativeness of that non-energy benefit. It's not just a Likert 1 to 7 scale saying, gosh, there's a barrier here and it's a 4. What do you do with a 4? What you can do with a $50 of problem is say we need to increase the incentive by $50, or we need to have an extra maintenance visit or something else like that that has really implementable information out of it. The NEBs, once we do this, the survey, the direct numbers give you numbers directly. Secondary gives you, a trivial change times a financial calculation. It's a number. Models give you direct numbers. Surveys, we go to the relative effect. We translate that to multiples, and we're able to come up with monetized numbers. All of these approaches give us real dollar values, which are what are really important. Beyond feeling good, we also have to have numbers we can put into real applications. NEBs have been used in marketing applications, partly because, gosh, selling on an energy guide is pretty hard. Selling on things like energy just got gorgeous, or other things makes it much easier. We don't see Tide selling by saying buy Tide because it makes us lots of money, or buy Tide because it's our highest profit item. We need to stop selling energy efficiency.
Hi, Lisa. I don't know if you can hear us. I think we've lost Lisa's audio. We will, if she's not aware of that, we will text her. And at this point, let's wait a second to Steve Scheller, the moderator, and see if she reconnects. If not, we will move on to our next presenter and then complete the rest of her presentation. Okay. Hi to the audience. Apologize for the audio difficulty here. We seem to have lost Lisa Skumat's connection here. So I think what we're going to do is move on directly to our next presenter and then hopefully get Lisa back on to conclude the rest of her information. If for some reason that doesn't happen, we do have Lisa's presentation itself will be available. So JP, are you ready to line up here?
Yes.
Okay, great. So let me introduce JP Carvalho is a Senior Scientific Energy Associate in the Electricity Markets and Policy Group at LBL. His research areas in the lab focus on regional resource planning, environmental and alternative energy policy. He holds a Master's in Energy and Resources at the University of California, an electrical engineering degree from a home university in Chile, and he's currently pursuing his PhD in Energy and Resources at UC Berkeley. So JP, if you can take it from there.
Excellent. Yes, thank you, Steve, for the invitation, and thank you everyone for attending, and I also apologize for the technical problems we're having. I'm going to talk very specifically about a quantitative analysis that we have developed on non-energy benefits, particularly focused in the U.S. energy service company or ESCO industry. The structure of this presentation, as I mentioned, is a data-driven analysis to quantify existing non-energy benefits in the U.S. ESCO industry, but not focus on costs. So we're focusing mostly on benefits reported by ESCOs themselves. We are interested in studying the trends for NEBs use in specifically energy savings performance contracting or ESPC projects, which is a typical and commonly used contracting mode by ESCOs in their energy efficiency retrofit projects. We also review a set of standardized methods to measure, monetize, and report NEBs, and briefly address some of the current challenges. And finally, I develop a short analysis on the economics of projects that include non-energy benefits to give you kind of a quantitative idea on how non-energy benefits affect the economics of ESCO projects. So our main source for data in this particular exercise is the LBNL Nesco database of projects, which is a unique database of 6,000 plus projects developed by ESCOs from the early 1990s. These projects belong to the accreditation process that's led by the National Association of ESCO Companies, and we take advantage of this accreditation process to compile and curate this database, which is quite unique in the world, and it's the largest database with costs and energy efficiency and non-energy savings in the world. For this particular analysis, we classify all the projects in the database in terms of the share of savings coming from non-energy benefits. So we define 4 categories. The non-category is where projects do not use non-energy benefits, so they do not report non-energy benefits. And this distinction is important because we rely on what the ESCOs report as non-energy benefits as part of their contract. This doesn't mean that there may be non-energy benefits that are not captured in this contract, and that's part of the challenges that I will talk a little bit later on. And then we have 3 categories: low, medium, and high. As you can see there, in terms of the percentage of non-energy benefits in dollar value that are part of the final result of the project. So in the case of the high level of non-energy benefits, this means that over 50% of the monetary savings are coming from sources that are not energy savings. And using this categorization, we have created this analysis. So what you're seeing here are 3 panels. The left-hand side is for the federal market. The center one is what we call the MUSH market, which is essentially state and local government, universities, schools, and healthcare. Essentially, it's an institutional market. And then to the right is the other market or category, which essentially comprises private sector projects. And what we see here in terms of the trends in time is that non-energy benefits are becoming much more prevalent. And for example, in the MUSH market, in the early 1990s, up to 3/4 of the projects would not include any single non-energy benefits, whereas in recent times, in recent days, only 25% of projects do not include non-energy benefits, which means that 3/4 of projects that are developed by the industry are reporting some sort of non-energy benefit. We can also see in the purple or color right at the top of these bars, that it's the use of high level or high amount of non-energy benefits is also increasing in time substantially from a little over 10% in the earlier 1990s to now over 30% of projects. So this means that a third of your projects in the niche market are relying on a high level of non-energy benefits to make them cost effective. We're going to dive now in the economics of NEBs, and this is a kind of preliminary slide that talks about policies related to non-energy benefits. And this is important because in many respects, the abilities of ESCOs to incorporate non-energy benefits are either hindered or at least impacted by decisions, policy decisions, or enabling legislation that allows them to do so. At the federal level, the Federal Energy Management Program, or FEMP, developed a methodology that recognizes only 3 non-energy benefits that are eligible to be quantified and monetized. These are decreased water and wastewater usage, reduced expenditures in operations and maintenance, and reduced repair and replacement expenditures. As you can remember from Lisa's slide, she showed a slide with probably 50 non-energy benefits, and in this case, we can see that in the FEMP methodology, only 3 of them are being currently captured and allowed to be recognized. At the state level, it's somehow different, and there's a broader allowance for non-energy benefits, and there is also a wide variation across states. What's important here is that there's little to no guidance in these regulations on how to quantify and monetize these non-energy benefits. And sometimes what happens is that ESCOs have developed customized methods to monetize the non-energy benefits, but this makes really hard comparison, and it makes really hard to for states to keep track of the different methods that different ESCOs within their jurisdiction are putting together. In particularly focusing on operations and maintenance savings, which is the most prevalent non-energy benefit that's reported in our database, there is a need to understand first the cost structure of O&M. So it's essentially, where are the savings coming from? There are, for example, costs of inventory that can be reduced, maintenance contracts that are revised. There is downtime that can be reduced as well through the energy efficiency intervention, and that downtime and overtime do have an economic impact. There are emergency repairs that are avoided. And so there's a host of different dimensions that has to be first understood. And then going to the second point, there has to be mechanisms that record and track both baseline data and ongoing data or monitoring to be able to track the evolution of the different cost components. Some examples of what's being done today is to track the scope and costs incurred in new maintenance contracts. And this has been quite complex because maintenance contracts do change their structure, so it's hard to compare the before and after. At the same time, there is labor and material costs for each equipment that have to be tracked. And again, depending on technological advances, the new labor and new material costs can be quite difficult to compare. Finally, user complaints is another more qualitative way of measuring impacts from an energy efficiency retrofit to have a externality of O&M savings. I want to briefly introduce the idea of a benefit cost ratio. So what you're seeing here to the left is a very simple cash flow stream of an initial project cost, and then a series of future savings or future streams of savings that are composed of both energy and non-energy savings. And to the right, you see the discounted future cash flow, and that means, and you can compare those benefits against the cost, and essentially when the benefits are larger than the cost, this is a profitable or cost-effective project. And I need to introduce this concept to present this analysis where we compare how does this benefit cost ratio changes for projects when we remove the non-energy benefits. So what we essentially do here is an analysis where we calculate the benefit cost ratio of projects including all the possible savings, and then we recalculate this excluding the non-energy benefits. And what we get here is this chart. So to the left, you have a panel with non or very low use of non-energy benefit projects. And to the right is the panel with a medium or high level of use. The red bar shows the benefit cost ratio, including everything, all the savings. And you can see that these are in the projects that have low use of non-energy benefits, they're slowly going down in time and reaching that threshold of 1, which marks the threshold for cost effectiveness. Whereas to the right, we have a much more stable situation where project economics are looking even better in recent years. But if we remove the non-energy benefits from this project and recalculate their economics, we can see that in the projects with high usage, they become non-cost effective. And this is evident from the green bars here. All the benefit cost ratios are below 1, which means that there's not enough benefits to make the project cost effective. So as a conclusion, this few points that summarize my presentation, the use of non-energy benefits is widespread throughout the U.S. ESCO industry, and particularly so in recent years as the use of NEBs are increasing over time. The projects with no use of non-energy benefits appear to be generally less attractive to these public and institutional customers. So they are effectively adding value, and they're increasingly doing so in recent years. And we also found in our analysis that these projects may not be cost-effective without these non-energy benefits. And so therefore, a conclusion and message is the need to standardize and quantify and to monetize a wider range of non-energy benefits to codify these methods in regulations at the state and federal level, and particularly focused on energy service performance in contracting projects. So thank you very much for your attention. This is my contact information, and I want to acknowledge a long-time collaboration with Nesco and the support of the U.S. Department of Energy's FEMP and WIC programs. Steve, I'll leave it up to you now.
Well, thank you, JP, for the presentation on that topic. I do have one clarifying question for you to confirm that the information you had on the value of the non-energy benefits, that was self-reported by the ESCOs. Was there any work, is it feasible to do work to confirm that with the customers of the ESCOs as to whether they received those benefits and valued them as indicated?
Yeah, that's a great question. So I'll answer in two parts. The second part first is that the Nesco accreditation process includes a round of phone calls and interviews with customers of ESCOs that are reporting these projects to confirm that the quantities and the impacts are as they report. And the second is that, going to the first part, effectively the non-energy benefits are reported by the ESCOs. And while they are ratified with the customers, it depends on what they put in the contract and what method they use, and we do not go into those details.
All right, well, thank you. I have a couple other clarifying questions on your presentation. We might try to handle those between us, JP, but I want to get back on schedule here and back to Lisa Skumat's presentation that was unfortunately interrupted by our audio difficulties. I'm going to go back to Lisa's slides and ask Lisa Skumat to continue with her presentation for about the next 10 minutes. And Lisa, I pulled up this slide. I'm not sure if that's the one you want to start with or somewhere else, but if you could take it from here, that'd be great. Lisa, are you on mute? Lisa, do we have you back?
You have me back.
There we go.
Okay. This will be a story in two parts, I guess. I was talking about that energy efficiency is not the best single thing to be marketing on. And in fact, when we do non-energy benefits interviews, the number one thing I hear from commercial customers is, I say, what about the energy savings? They say, I'm not sure we actually got any. So assuming that that's the best thing to market on is a weak thing. Utilities have been doing marketing over the last number of years, looking at marketing on other things than energy savings, including comfort and things like water savings and others as well. So I wanted to give you an idea of some of the NEBs values that we're finding as well. And are NEBs high value? Absolutely. We're finding that in a number of programs and over again that the NEB savings, the NEB value exceeds the energy savings, often by multiples, especially when you're considering participant savings. And the other really big one is the societal savings. The utility savings tend not to be quite as much, the utility NEBs. There are a number of residential programs that have been NEB'd, scores and scores of them. The top NEBs for different kinds of programs include things like for weatherization programs, it's comfort and ability to control your bills. For Energy Star, a number of Energy Star appliances like dishwashers and clothes washers, it was water savings. For programs in New Zealand, you have to be, respect the locals. And dampness and mold was a really big thing, and NEBs can pull that out. For an Energy Star programs, it was the look and the housing value benefits that they got out of the program. For commercial and industrial programs, we see a whole variety of programs NEB'd again, and some of the benefits that come out of those, including some of the audit and financial programs, were lower product loss, better productivity, greater lifetime of measures. For new construction programs, we saw such things as tenant satisfaction. For technical assistance programs, we saw things like safety. A whole variety of things come across in NEBs evaluations. You can also express the NEBs in a number of different ways. Here for a commissioning program, we express the NEBs in terms of dollars per square foot and other things that people could use in a variety of different ways as they move forward with the programs. I want to mention that NEBs are a barrier. Negative NEBs represent barriers to programs. We sometimes find negative NEBs for individual NEB categories, but not for NEBs overall, not for non-energy impacts as a whole. But the ones that we tend to find not negative effects on include things like appearance and maintenance. We found it here in a program in New Zealand where we found that solar water heat and solar design was found to be unattractive and that there were maintenance worries. We often find that high-tech, latest HVAC systems for commercial sector there are worries about the maintenance for those pieces of equipment. Can the maintenance staff in building keep it up? Can Joe's contractor down the street actually keep it up? In those cases, we find dollar amounts that can tell us how much we need to add to the incentive, have as the value of a maintenance visit or something else to get people to zero, to get people to negative, to get people past the barrier. It's a lot more illustrative and actionable than a 1 to 7 Likert scale that you get in most process evaluations, which are much weaker. You can also make sure that all people along the line are in sync on what they think about non-energy benefits from the program. In one program that we did, we found that the architects and engineers were specifying less energy efficiency than the owners wanted to buy. Ultimately, there were energy efficiency and savings left on the table. Societal NEBs are also significant. The jobs and economic impacts are really strong and are different between different kinds of programs. Retrofit programs are far more job and economic intensive than our appliance programs, and this last one talks about the economic effects in the U.S. versus various states, and at least some of the insulation, other things are made in the U.S. Appliances appear not to be anymore. Emissions are also something that's a big impact, and they tend to be pretty stable unless differences between peak and non-peak programs. But once you know the generation mix and do this modeling work, it tends to be incorporated as an adder in different programs. NEBs have been widely researched for the last 20+ years, and there are hundreds of studies on the programs, the measures, and so on, nationally and internationally on a wide variety of program types. There's been a lot of progress, especially in single-family and commercial programs and measures. Multifamily has been less commonly studied, and we're also working more and more on individual measures. A lot of program-wide stuff has happened, but you don't know how to mix and match measures because measure-level work has been done, but not quite as often. There's been a wide variety of measures and NEBs, but some of the gaps include some of the specialized process C&I measures and health impacts. We're seeing a lot of international work on health. I'm working with the IEA and others on some of that work, but that's an area where there's been a gap. But the methods are strong. There have been refinements in that over time and mixed approaches to try to home in on numbers. The literature has been assembled into models to allow for quick response information on what NEBs are for specific programs or program types. And as I mentioned, these measurement techniques for the participant NEBs are very, very easily added into process or impact surveys, and that's a very small dollar amount to get a big bang in terms of better and more actionable information out of the process evaluations, not only in terms of strengths and barriers for the programs, but in their applicability to looking at benefit costs and other applications. Even a NEB as small as 1.25, let's say, has a very dramatic effect. These are dollar amounts. 1.25 times the energy savings. That's a value of 100% halves the payback and doubles the ROI. If you're at a gross payback of 5.6 years, adding in NEBs of the value I mentioned could bring that to 2.5 years. If you have a benefit cost that included the participant NEBs of 1.25, then you could move the benefit cost from 0.9 up to 1.9. It really has a dramatic effect. And we've seen NEB multipliers in terms of energy savings anywhere from 25% to 300%, depending on the measure, the target, the climate, and other things. They're very dramatic. NEBs have been applied to benefit cost in recent years, again, after initial forays in the early 2000s. And they're a natural part of the TRC and societal tests and other things like that. If you're going to have a true representation of benefits and costs, and particularly the benefits, then elements of NEBs directly address the missing factors from that and reduce the bias that's embedded in the benefit cost test as it currently is specified. They better guide measure, program, and portfolio investment. And you can address it a couple of ways. I'll give you that. You can address it by including monetized NEBs, which is probably the approach I might take in most cases. You could alternatively exclude all the costs associated with achieving the NEBs, or you could use the utility cost test, but that's not what people are using. Benefit costs, as I mentioned, were considered early on, then pulled back because people wanted to weight more quantitative evidence. It was a bit of a chicken and egg issue. If it wasn't going to be applied to important uses, there wasn't money to look at NEBs, and benefit cost is an important use. But during the you get more money if it's a serious application, but you can't get the serious application unless you've spent enough money to see that the literature shows strength and consistency in results. There's been much investment since that time, data, expertise, and over the 20 years there have been a lot of progress. And now states have come on, and more and more states in domino fashion have come on to consider NEBs in their benefit cost work. There's been exhaustive research on a state-by-state treatment of NEBs in benefit cost applications across the U.S. and Canada. There's also extensive research on the corrections that you need to the traditional benefit cost tests in order to consider NEBs. I hear a lot of concerns that, gee, aren't NEBs too inaccurate to consider in a benefit cost equation? And what I might argue is that the benefit cost equation is a function of the present value of savings times, if I would add NEBs, times the lifetime of those savings times the net to gross factor. And you divide that by cost factors. Well, all the things in blue are things that aren't actually written in stone. And savings we do a lot of studies. I'll grant you the savings number is relatively accurate. We see that over and over again. But I see numbers anywhere from 1% to 8% for the present value factor. I see lifetimes that have been established 20 plus years ago on old technologies, and they were in some cases established not by statistics but by consensus phone calls. I see net to gross factors that sometimes include only free ridership, sometimes include net to spillover, and are often survey based. So actually net to gross or non-energy benefits is not the least accurate number in this whole set of equations. The methods to include NEBs in regulatory tests include an adder basis, readily measured NEBs, hybrid basis, which includes both readily measured and adders, and all non-energy benefits. And adder means something that stays the same across all the, just multiplied times the savings. And certainly if you're going looking for the most accurate, the most tailored, and what maximizes DSM opportunities, you're going to go toward including all NEBs. But if you're a regulatory agency and you want to minimize regulatory risk or implement a risk, you would lean back towards the adders. If you want to minimize evaluation costs, you would also lean back toward the adders. States around the U.S. have included NEBs in different levels, adders, readily measured, hybrid, and all-in. And they're in various stages of deliberations in other states, working groups, TRM working groups, and so on. And we've been working in areas in the Midwest, in the Mid-Atlantic, and elsewhere. This domino effect has really taken hold. NEBs are useful in evaluation results. The rankings tell the strengths and marketable features. The dollars inform ROI and payback and benefit cost tests. The barriers suggest concerns and interventions needed for your program. The values affect the measure, program design, and targets. And the gaps suggest training needs. The takeaways are NEBs and non-energy impacts are well-researched, quantified, and have vetted measurement methods. They're valuable and, frankly, more valuable to customers than energy efficiency in many cases, and easier to market. There's a lot of data, some gaps, but they're easily measured, and they can and should be part of process evaluation surveys, I think. They're a better way of measuring traditional barriers and strengths, and more implementable and more actionable than the Likert scales that I often see in those evaluations. It improves and reduces the bias in benefit cost testing, which is spreading nationally. Thank you for holding tight for phase 2.
Thank you very much, Lisa, for getting through all that information. And we're now going to allow us to continue in our plan for boy-girl presentations with our next presenter. Let me get over to his slides. So we skip over JP's here. And actually, I guess we are going back to a person from, excuse me, I guess I've gotten messed up in our time here, so I apologize for that. So our next presentation is from Minnesota, and it is Ms. Burdett, who manages the Minnesota State Energy Office, which is housed within their Department of Commerce. And she specializes in energy efficiency assurance and operations. Her responsibilities include oversight of 180 electric and natural gas energy efficiency programs designed to meet the statewide efficiency resource standard. She also is involved in administration of public sector energy efficiency and renewable technology assistance programs and efficiency renewable project financing, and the coordination of their emergency response for relating to energy. She's a Iowa State University alumni, and with that, Jessica, if you could take it from here.
Thanks, Stephen. I appreciate the introduction. And thanks, everyone, for the opportunity to come speak to you about some of Minnesota's experience in evaluating non-energy impacts. Let me get the slides here. Okay, so Minnesota has a long and rich history of energy efficiency programs. We've had many programs in place for well over 30 years, including the Conservation Improvement Program, which I'll speak a little bit about today. We also have our statewide Sustainable Buildings 2030 Energy Standard programs related to wastewater treatment efficiency, lead by example, programs like the Guaranteed Energy Savings Program that supports performance contracting in the public sector, weatherization assistance, and many more. So today I'm going to use two examples of our Conservation Improvement Program and our Sustainable Buildings 2030 program and demonstrate how we have used or evaluated non-energy impacts in these programs. So first, our Conservation Improvement Program is the program that delivers the Energy Efficiency Resource Standard. All 180 plus of our utilities, minus a few small natural gas utilities, are required to meet a 1.5 annual energy savings goal. This can be adjusted to 1% by the Commissioner of Commerce, and it has been adjusted for the natural gas utilities. We have 9 investor-owned utilities, 130 municipal utilities, and 44 distribution cooperatives that all have programs to meet the goals. We have over 2,000 unique programs that are currently being administered by utilities. There's always a question around what the economic impact is associated with our programs to meet the EERS. And so we procured the services of the Cadmus Group to perform a economic impact analysis for us, looking at all of our utility programs using data that we've collected from 2008 to 2013. So with that evaluation, there were two primary components. We looked at an overarching cost effectiveness assessment, looking at the benefits and the costs versus the costs of the program or the portfolio. We looked at multiple perspectives using the California standard practices, utility test, societal, participant, ratepayer impact, and total resource cost test. And then we also looked at the impact on utility rates through the lens of the ratepayer impact test. And then we also looked at using the in-plan model, which is a model that basically looks at a snapshot in time of the economic impact of this particular program. We looked at the impacts on employment, earnings, income, and savings for both individual consumers and businesses. We looked at revenue and production, the impact on investment and innovation, as well as state domestic product. The combination of these two assessments gave us an analysis of the aggregate economic impact of the Conservation Improvement Program on the state of Minnesota. So what we found, here's a summary of the results, that over 8,000 direct jobs were created, and there was around $2 billion in net employee earnings that were delivered from these programs. There were significant household income and savings, just over estimated around 2.2 to 2.6 billion. And then there was around $5 billion estimated impact on revenue and production. And then overall, skipping to kind of the bottom line talking point that we often refer to is the societal cost test indicates that for every $1 invested in energy efficiency programs, we receive a $4 to $4.35 return on investment. And as other states have conducted similar economic impact analysis, they are finding similar results. There are a couple of reasons why we felt this was an important study to conduct, as well as different considerations that we should make in terms of how we use this information moving forward. Overall, this economic analysis has provided some rigor and support for our public policy decisions to prioritize efficiency, recognizing it's a least cost resource and should be prioritized over all other supply side resources. This helps us further support not necessarily that it's a least cost resource, but that as a public policy, not only are there benefits of it being a least cost resource, but it also is a generator of positive economic impacts. So we can also look at this as saying, efficiency supports the other objectives around economic development for the state, and supporting our, different networks of installers, operators, maintenance providers, architects, engineers, and technologies, and ensuring that we have a healthy workforce that can deliver on these, and that we should be focused on using efficiency at some level to support these programs as a result of the economic benefits. So some considerations, we often get asked by, various stakeholders in the state as to, should we be including economic impacts as a metric in our cost effectiveness tests. For our programs, everything lives and dies by the societal test. And we do have instances already where we have included non-energy impacts, the externalities and carbon emissions are included in our societal test. And so would it make sense to include economic impacts in our societal test? I think there are a lot of pros and cons to that as a possibility. I think one of the reasons why, or there's a couple of reasons why we haven't moved forward with doing something like that. We hadn't to date had a lot of rigor behind estimating the economic impacts. And so how do we need to work in, analyzing the economic impacts on a regular basis to say that, yes, we have a good number, good solid numbers with rigor and methodology behind them that could be included in this test. Now, while we're maybe more able to fully realize the value of energy efficiency with these non-energy impacts, is there the potential that we end up inflating the value of efficiency and ultimately start turning these programs or the justification for these programs, they start to look more like public benefits programs? And should our ratepayers be paying for programs that are essentially starting to look like public benefits programs? And I think there's a lot of question about the ratepayer equity for that and having those ratepayers paying for investments that, are not necessarily just being valued for their energy benefits, but for other non-energy benefits. And so I think there are some questions around ratepayer equity around on including these in our cost effectiveness tests. So moving on to another example where we've looked at non-energy benefits is in our B3 program, which includes a energy standard called Sustainable Buildings 2030 Energy Standard. At a very high level, our B3 guidelines, all of our facilities that really receive general obligation bonds for new construction or for major renovations are required to meet the B3 guidelines and the SB 2030 energy standard. The guidelines include design criteria and operating criteria for things like waste, water management, energy operations management, siting, and a variety of other things. So we have pre-design, design guidelines, construction, and operations. And I'll draw your attention to the slide in the bottom right-hand corner. There is a post-occupancy evaluation function after the building becomes fully operational. The idea behind this is to look at post-occupancy evaluation, occupant comfort, as a means of determining how well the building was designed and is performing. And the idea that, occupant comfort in one of these facilities is really important, that, it could lead to greater worker productivity, and that ultimately the building operators answer to those occupants in the building. And so we wanted to look at, specifically occupant comfort as a way to maybe establish a non-energy impact or non-energy benefit that can be used for a variety of reasons. So how we determine post-occupancy comfort is through conducting a survey, much like what Lisa Stumatz was presenting earlier in her presentation. We have the occupants of the building fill out a survey looking at answering to a few different qualities of the building, including, acoustic quality, appearance, cleaning, daylighting conditions, furnishings, air quality, privacy, thermal conditions, and we ask them to rank their satisfaction or dissatisfaction on a scale of 1 to 7, and then there is some weighting of the responses, and those are then used to determine a score. And as you see on the bottom right hand of the slide, we have this Guideline Scorecard, which basically benchmarks the different B3 guidelines, including waste, water management, energy, etc. And the very bottom of that scorecard is the indoor environmental quality that is informed through the post-occupancy evaluation. On the bottom left hand of the slide here is the actual IEQ scorecard pulled out for the Hennepin County Sheriff's Office, which is a dispatch center. And the post-occupancy evaluation results indicate that for the most part, the occupants are satisfied. And we have seen a variety of results, from these post-occupancy evaluations that have been completed. We haven't yet been able to go the distance into, being able to monetize what that value means, but I think that is something that we are considering for discussion and future development of this metric. So, part of the purpose is that as we are benchmarking some of the other performance metrics, we felt that post-occupancy comfort was something to be benchmarked and considered. This information can be used when you drill down into the details of the scoring to make operational improvements to the facility, that if we find that everyone scores thermal comfort at a very low score and very dissatisfied, that we can make improvements. We can identify where there maybe we need to make operational improvements. It also can provide feedback to the design guidelines and criteria, so that we're able to better design buildings and ensure that occupant comfort is being better addressed if we are seeing significant program design issues or facility design issues. And so these benchmarks overall help provide a feedback loop to improve the program. Then, for other considerations, can we use something like post-occupancy evaluations to add other non-energy impacts to other energy efficiency programs? And I think that, there are a lot of pros and cons to that, some of which I articulated when you think about the ratepayer-funded programs, but there are options. These are options to be considered. So, in conclusion, something to consider. While we often refer to non-energy benefits, sometimes there are costs and associated with non-energy attributes, and so the impact should be. So we should actually consider these as non-energy impacts to account for both the costs and the benefits. These non-energy impacts can be useful for determining the full value of efficiency as well as for public policy development, but their use should be carefully considered and weighed before including them in some of the ratepayer-funded programs. So with that, I'll hand this back to Steve so we can move on to next presentation. Thanks, everyone.
Great. Thank you very much, and Jessica. And we've gotten some clarifying questions, but I think we've been able to handle most of them with individual text responses. So want to turn to our last, but certainly not least, presenter. And Matt, thanks for bedding cleanup for us. And please, do your full presentation. And as we have time, we will do a little bit of Q&A at the end. But please complete your presentation. So let me introduce Matt Clutcher. He's the Director of Rate and Demand Resources at the Arkansas Public Service Commission. He's been there about 7 years, and he's responsible for coordinating and developing the staff's recommendations, utility filings regarding a variety of issues around demand resources, including cost allocation, rate design, tariff, et cetera. And he directs other staff members in analyzing these utility filings. So with that, Matt, please share with us what's happening in Arkansas.
Thank you, Steve. Again, here in Arkansas, we've been doing energy efficiency programs at our investor-owned utilities since about 2008. We're about 8 years into it, and we recently started implementing non-energy benefits into our EM&V of our program. Our EM&V came about through a working group that we work collaboratively here in Arkansas to help basically address lots of issues regarding energy efficiency. In December of 2015, the Commission just recently approved 3 categories of NEBs to be used in evaluating programs, specifically in the TRC test. And these NEBs will not be used for evaluation until the evaluation of our next three-year cycle for our programs, which will begin in 2017. So we haven't yet had an evaluation year with our new NEBs, but they will start next year. Utilities will start using those for their evaluations. Kind of give you a background on how we came about the collaboratively developed NEBs here in Arkansas. So for many EE issues here, we have a collaborative model, and we refer to this group as the parties working collaboratively, or the PWC. And it basically consists of a lot of stakeholders here in the state who have a direct interest in EE initiatives here in the state. This includes our 7 public traded utilities, general staff, which I'm part of here at the Commission, Attorney General's Office, and various other stakeholder groups that include Autobahn, Sierra Club, the Arkansas Advanced Energy Association, and also includes our independent EM&V monitor, or IEM, which I'll talk about more later in my presentation. But the PWC basically works together to develop recommendations to the Commission for its consideration. Gives us the opportunity to discuss our issues in a more informal setting than through general testimonies and hearings. So for non-energy benefits, back in January of 2013, the Commission issued a docket here, 13002U, and you can, if you have access to our Commission website, and you can go and review everything we've done in this docket. But this particular docket addressed a number of issues regarding energy efficiency, and specifically NEBs for use in the total resource cost test, the TRC. And the Commission directed the PWC to work collaboratively to identify appropriate NEBs for use here in Arkansas. And so the PWC responded to that order several months later, requesting time to do that. And during our discussions, the PWC did agree that the TRC test could be improved if we included the appropriate NEBs, and after that, additional time. In September of 2013, the Commission did grant the PWC the time they requested to address NEBs, but the Commission actually gave us some clearer directions on what we were supposed to do in our NEBs evaluation. The Commission directed that the TRC test should include well-defined NEBs, which measurably reduce the use of scarce resources, have quantifiable economic values, and are clearly applicable to specific program or measures at issues. And so over the next year, in 2014, the PWC used that as its guideline to start evaluating what NEBs we could recommend to the Commission for use. Now, our NEBs working group was led by experts in our IEM team. It's our independent evaluation monitor here in the state. So in our 7 investor-owned utilities, they hire independent consultants to do their EM&V, and as staff, what we have is an independent monitor who overlooks those for us. This helps ensure consistency for EM&V amongst our 7 utilities. That's something we strive for here in the state of Arkansas, is to make sure everything we do is consistent from utility to utility, and we are working for that same method to make sure our NEBs are implemented consistently from utility to utility as well. But during our process that year, the PWC identified what we believed were the most important and reasonably quantified NEBs to include. And so these include other fuels, which essentially means that if a electric company goes into a house and does a weatherization program and that customer uses gas, well, that gas is also a savings that's happening. avoided water, sewage, and then, of course, avoided and deferred equipment replacement. We made a recommendation to the Commission which consisted of 4 different recommendations ranging from 0 NEBs to be included up to those that we had listed there. The Commission in December of 2015 did issue the order on NEBs, and it found that the following 3 NEB categories were going to be included, which again was those same ones that we had addressed before, which was the other fuels, public water and wastewater, and deferred equipment replacement costs. The Commission directed that the IEM team be requested to recommend an approach for the quantification of deferred equipment. This was to ensure that when utilities were evaluating deferred equipment costs, that we had a similar fashion in which each utility would address that, and that the quantification of NEBs be included in our technical reference manual. The IEM team here in the state also helps us maintain a TRM that we update on an annual basis, and the Commission directed that the 3 categories of NEBs and how they would be consistently applied to the program evaluation be included in our TRM. So what we've done here was we took our TRM and we've actually included how we would go about identifying the NEBs and how to calculate those. And again, as I mentioned, the approved NEBs will be ready for evaluation in 2017. And if you go to our TRM here in the state of Arkansas and you look at our Protocol L, it will outline how our state is going to implement the 3 categories of NEBs. And what this essentially does is it gives a guideline to the utilities and their evaluators on how to apply these NEBs to their programs, and also gives our IEMT the ability to go back and make sure they are being applied consistently throughout the evaluation of programs. But again, our 3 main categories are going to be the other savings, public water and wastewater, and avoided and deferred equipment replacement costs. Here in Arkansas, the PwC decided those were the easiest ones to quantify, and since the Commission told us they needed to be quantified, this is the ones that we're using at this point in time. So that is a quick summary of the experience of Arkansas, how we've gotten through NEBs here. So again, we haven't actually had evaluation, but we have got them put in place and how we're going to use them. And if you are interested, I've had some links here to the Commission website in which you can go and look at our TRM. And if you go to the Protocol L, of course, it will tell you more about how NEBs are handled here in the state of Arkansas. That concludes my presentation.
Great, Matt. Thank you very much for that, and succinctly going over a lot of the work that's been done in Arkansas, and Jessica prior to that for going over all the work that's happening in Minnesota. So I think with our webinar so far, we've had the background and context and the evaluation strategies presented by Lisa Skumatz, and then for how this is being applied for JP to talk about how that's being done in ESCO projects, and then Jessica and Matt talking about the application in 2 states for public funded and utility customer funded programs. We've had a number of questions that have come in, and hopefully we've been able to respond to them via the presentations themselves or the text boxes. But there has been a general question that sort of flowed through a lot here, and I want to ask all of our presenters as we conclude here, and we might run over a minute or 2 late, and hopefully the audience can stay with us. For each of you, perhaps going in the order of our speakers, to talk a little bit about, in practice, how important is the quantification of non-energy impacts, non-energy benefits in evaluating efficiency programs and portfolios, and how important is the consistency in that EM&V across the jurisdictions? So maybe some quick thoughts you have on that would be great.
Sure. This is Lisa. Can you hear me?
Yes, we can. Thank you.
Just a little nervous about that. Okay. So I'll answer in reverse order. 1, is it important to consistently measure NEBs? I think that there's a strong literature and large literature on best practices and academic approaches that are really reliable. While I'm not a big fan of protocols that are too restrictive, I think that we should be looking for a certain quality or above, but I do like creativity, flexibility, and continuous improvement. So I guess I would say at least the best that exists, but with an eye toward always improving. Whether or not to do how important are NEBs for measuring, especially when you may not have it already required or requested by regulators, or regulators aren't even interested or something? I think it's really important. I think that NEBs have so many other interim uses: marketing, benefit costs, barriers, marketing and barriers and all those sorts of things, that it's really a valuable tool. Also, one state did something kind of interesting. They measured NEBs before the regulators were interested in it, and they presented the benefit cost information with NEBs, without NEBs, and with a portion of the NEBs, just to show the regulators what difference it could make and what programs were particularly benefited by the inclusion of NEBs, and especially ones that might be close. And that, if you do NEBs work as well, if you measure NEBs in the near term, and even if it's not necessarily required, it's cheap, but you also accumulate then a body of local literature that then you can use and have on hand. And we've found that to be really useful when we've worked with regulators and preparing testimony and working with TRM working groups. It really, really helps us to have local information on NEBs for the programs at that utility. So preparing that body of literature for the ultimate use of in benefit cost work. I think not including NEBs in benefit cost is biasing, and that's a problem. We're underinvesting in energy efficiency.
Thanks, JP.
Yes, well, I think the first part of your question is exactly what I addressed with my analysis. Essentially, we demonstrate that quantifying NEBs is fundamental to make project cost effective and be recognized as such in contracts in the ESCO industry. And as we saw in cases where larger use of NEBs is reported, those projects wouldn't have been done should those NEBs have not been recognized. So it's, and we also know that we're missing a lot of non-energy benefits in that quantification and monetization. So those projects are probably even more cost effective, but we're not able to recognize that, and it means that the essentially cost of saved energy is larger than it could be numerically speaking. The importance about consistent EM&V, I think, is that the wider recognition of NEBs and the easier incorporation in contractual form would be fostered if there was this consistency across jurisdictions, if there was clear methodologies reported or structured in regulations, then there will not be this doubts or skepticism that usually arises when quantifying and monetizing non-energy benefits. Everyone will be on the same page, and that would make much easier and reduce transaction costs of incorporating these monetary values in contract between ESCOs and their clients, and more generally across energy efficiency programs in other institutions or arrangements.
Thanks. Jessica, any thoughts on that?
Yeah, so how our ratepayer-funded programs are designed, each individual utility administers them. And so we have designed it that way because utilities know their service territories best. We think that there's more innovation that can come from the utilities, doing it themselves and working with their chosen vendors to develop these programs. But the challenge that presents to us as regulators is that always we are chasing after consistency. And so where we find consistency is important, we focus on consistency around methodologies for determining assumptions that are used in developing cost-benefit tests, or the inputs for cost-benefit tests, inputs for the determination of energy savings, et cetera. And so to the extent that we can standardize the methodologies that would be used to determine the non-energy impacts, that is what's desirable for us. We don't want to try and construct a framework that fits one utility, for instance, our largest investor-owned in the state that has 50% of the load. apply a construct that works for them, and then try and apply that to you know, a small municipal utility with 400 meters in its system. So consistency is important to a degree, but we do also value flexibility, and so it's always trying to strike that balance.
Great. And then Matt, you want to clean it up for us?
Sure. So as far as the question about how important the quantification of NEBs, I mean, you know, our commission here in the state has made the point to say that they found NEBs to be important. But again, what our commission also has a strong focus on is making sure that they're quantifiable. So, you know, that we find the NEBs here to be important as long as they are quantifiable and measurable and can be applied to the appropriate programs. You know, I think I addressed some of that in my presentation, and especially on the part of the consistency. Again, we develop guidelines that we, again, have in our TRM that shows how a evaluator should go through evaluating the programs, including how to incorporate the NEBs within the particular programs. And again, our identification of those particular NEBs kind of make it work regardless of size or the location of utility, since it really focuses on those that are quantifiable in nature. And so it lends itself well to our protocols in our TRM manual, which addresses the consistency that we like to have here in our state when doing energy efficiency, whether it's on the EM&V side or even reporting methods.
Well, great. Well, thank you. Thank you very much to our presenters today for taking the time and the effort to prepare the informative discussions that they had there. As mentioned before, these will all be up on the EM&V LBL webinar website within a day or so. And please join us for our next webinar in probably end of January, beginning of February of 2017. So thank you all, and thank you, audience, for joining us, and have a great rest of your day.